When Galileo Galilei first turned his telescope toward Saturn in July 1610, he described what he saw as a large planet in the middle, with two smaller ones on either side. But in the years that followed, those two planets would appear, then disappear, leaving him completely baffled. It wasn't until 1659 that the Dutch astronomer Christian Huygens finally solved the mystery with a more powerful telescope. The objects Galileo had described were not planets at all, but a thin, flat ring system surrounding Saturn. The rings only seem to disappear because their angle changes as seen from Earth. For centuries, those rings have been one of the most iconic sights in the solar system, but they won't remain that way forever. Scientists believe the day will eventually come when Saturn loses the feature it is best known for. Yet, that's only the beginning. Behind its familiar appearance lie mysteries even stranger than the rings themselves. Saturn is home to a nearly perfect hexagonal storm that has endured for decades. Beneath the frozen surfaces of its moons are oceans that may be capable of supporting life. And above all, there is the story of the Cassini spacecraft, whose final mission was planned by NASA years before it came to an end. But before we explore all of that, let's first get to know the main character of our journey: Saturn. Saturn is the second largest planet in the solar system, large enough to fit more than 700 Earths inside. But despite that massive size, it's a low-density world. While water has a density of 1 gram per cubic centimeter, Saturn's density is just 0.69. If you could find a bathtub big enough to hold it, Saturn would just float on water. The explanation is simple. Unlike Earth, Saturn isn't a solid world. It's made almost entirely of hydrogen and helium, making it more like a giant sphere of gas than a rocky planet. It's also spinning incredibly fast. One full rotation takes just 10.5 hours. Spinning this quickly causes the planet to bulge around its equator and flatten slightly at the poles, giving Saturn its distinctive squashed shape. Days here are short, but the years are far longer. It takes nearly 30 Earth years to complete a single orbit around the Sun. For centuries, that was almost everything we knew about this distant giant. Then, in 2004, Cassini arrived. For the next 13 years, the spacecraft explored Saturn and its moons up close, transforming our understanding of the entire system. Much of what we know about Saturn today comes from that mission. And one of Cassini's first revelations was that Saturn's most famous feature wasn't as simple as it looked. Mention Saturn, and the first thing that comes to mind is its stunning ring system. From a distance, they look like a single, solid disk. In reality, they're made of billions of separate pieces of water ice, mixed with a small amount of rocky dust. Some particles are smaller than grains of sand, while others are as large as houses. The rings aren't continuous either. They're divided into several broad bands, separated by huge, empty spaces. One of the largest is the Cassini division, discovered all the way back in the 17th century by Giovanni Cassini. But if these rings are made of countless loose pieces of ice, why haven't they drifted apart over billions of years? The answer lies with a handful of tiny moons known as shepherd moons. Moons like Prometheus, Pandora, and Daphnis orbit alongside the rings, using their gravity to keep those icy particles confined to narrow paths. As Daphnis travels through the A ring, it creates rippling waves in the surrounding ice, much like the wake of a boat moving across calm water. Even with those tiny moons keeping the rings in place, it won't last forever. Saturn's gravity is constantly dragging material into the planet's atmosphere, creating a steady rain of ice, known as ring rain. At this pace, scientists estimate the rings could disappear within 300 million years. That may sound like a very long time, but in the lifetime of the solar system, it's only a brief moment. We just happen to be alive at the right time, witnessing Saturn while its iconic rings are still here to be seen. But Saturn still holds its cards close. Across the B-ring, strange, dark, and bright streaks, known as spokes, appear and disappear without warning. Gravity alone shouldn't be able to produce patterns like these. The best guess we have is that electrical forces briefly lift tiny dust particles above the ring surface, but no one knows for certain. By now, it's clear that Saturn's rings aren't the simple structures we once imagined, but the planet beneath them is even harder to understand. You might expect a planet this far from the Sun to be cold, quiet, and uneventful. In fact, Saturn has one of the most dynamic atmospheres in the entire solar system. Nothing shows that better than what's happening at its North Pole. There, a giant storm has held the shape of a nearly perfect hexagon for decades. It stretches across a region larger than Earth, and despite years of observations, it has barely changed. Since it was first photographed decades ago, the hexagon has remained stable, rotating around the pole as though it were anchored in place. Laboratory experiments have shown that fast-moving fluids can naturally settle into polygon-shaped patterns under the right conditions. Scientists think the same physics may be at work deep within Saturn's atmosphere, but after decades of research, the hexagon remains one of the planet's biggest mysteries. Near the equator, powerful jet streams race around the planet at speeds approaching 1,800 kilometers per hour. More than 4 times faster than the strongest hurricanes ever recorded on Earth. For decades, scientists assumed a world so far from the Sun should have a relatively quiet atmosphere. Instead, Saturn proved the opposite. The planet releases nearly twice as much energy as it receives from the Sun. That extra heat rises from deep within the planet, helping to drive weather on a truly global scale. Like Earth, Saturn's axis is tilted, giving it spring, summer, autumn, and winter. But one trip around the Sun takes almost 30 Earth years, so each season lasts for more than 7 years. Over time, the cloud bands slowly brighten, fade, and shift with the changing seasons. No matter how much we learned about Saturn's atmosphere, the biggest surprises weren't waiting inside the planet. Behind the beauty of the rings lies an entire system of worlds that may hold the answer to one of humanity's biggest questions. Are we alone in the universe? By the time Cassini reached Saturn, we already knew the planet had many moons. Today, more than 140 have been confirmed in orbit around it. Most are small, icy bodies, hard to tell apart from countless other objects in the solar system, but a few stand apart from anything we've seen before. Let's start with Titan. As Saturn's largest moon, Titan is considered a natural prebiotic laboratory. It holds a chemical environment rich in organic compounds, closely resembling early Earth before life appeared. Titan's atmosphere is about 95% nitrogen and 5% methane. This composition is strikingly similar to Earth's atmosphere roughly 4 billion years ago. Sunlight and high-energy particles from Saturn's magnetic field constantly strike it. This breaks apart nitrogen and methane molecules, forcing them to recombine into complex organic compounds called tholins. These substances form the orange haze covering the moon and continuously rain down onto its surface. In about 5 billion years, the Sun will run out of fuel and swell into a red giant. At that point, the solar system's habitable zone will shift outward, warming the region around Saturn. The ice on Titan will melt into liquid water, and its atmosphere will grow warmer. Titan will then finally have every condition needed for life to emerge, much like Earth does today. If Titan is a laboratory for studying how life begins, Enceladus is the top candidate for where life might already exist. Beneath Enceladus's thick ice shell lies a vast liquid saltwater ocean. Pressure from below drives geysers that shoot massive plumes of ice and vapor into space. These plumes carry material from the ocean underneath up into space, allowing Cassini to fly through them and analyze their composition directly. In biology, life as we know it requires 3 basic ingredients: liquid water, organic
matter is the material required to drive these chemical reactions.
Remarkably, Cassini found all three within these plumes. In other words, one of the most promising places to search for life beyond Earth may not be Mars, but hidden beneath the ice of a small moon orbiting Saturn. Cassini's mission exceeded every original expectation. It didn't just deepen our understanding of Saturn, it turned Titan and Enceladus into two of the most important targets in the search for life beyond Earth. But because of these discoveries, NASA was forced to make an unprecedented decision. For 13 years, it orbited Saturn, watching the planet through changing seasons, flying past its moons, and revealing a planetary system unlike anything we had ever imagined. But every mission has to end. By 2017, Cassini was running low on fuel, and without enough fuel to control its course, the spacecraft could eventually crash into one of Saturn's moons. Moons like Titan and Enceladus might actually host life. If even a single microbe carried from Earth survived the crash, it could contaminate those pristine worlds and ruin our chance of ever finding true alien life. So, NASA made a bold decision. Instead of risking a crash, they chose to destroy the spacecraft on purpose. In its final weeks, Cassini pulled off one last daredevil move, diving right through the narrow gap between Saturn and its innermost rings, a place no spacecraft had ever dared to go. Then, on the 15th of September 2017, Cassini entered Saturn's atmosphere for the very last time. As the intense heat and pressure rose, it kept fighting, beaming data back to Earth until the very last second. Its final signal only faded away when the spacecraft lost control and burned up high above the clouds. More than 400 years ago, Galileo looked at Saturn through a primitive telescope and thought the planet had ears. Today, we've mapped those rings in microscopic detail, tasted the geysers of Enceladus, and landed a probe on Titan. We've uncovered a system that Galileo could never have dreamed of. And yet, Saturn is still guarding its secrets. We're still scratching our heads over how that polar hexagon formed, what chemical weirdness is brewing in the thick orange skies of Titan, or whether something is swimming in the dark oceans of Enceladus. But we're going back. NASA's Dragonfly drone is already preparing to fly through the skies of Titan, and future missions will eventually dive deeper into Enceladus than ever before. Cassini's journey is over, but our story with Saturn is just getting started. If you loved exploring this giant world with me today, hit that subscribe button so you don't miss our next voyage into the deep cosmos. There are still billions of worlds waiting for us out there. Thanks for watching, and I'll see you in the next one.